So in this exercise and tutorial, we're going to cover more how to create or use FIS error models that have already been created. So I've got an empty ArcMap, a new empty ArcMap document. I'm going to go ahead and save it into the folder where I have this exercise. So CHaMP O_CHaMP FIS. I'm going to go into this other folder and I'm going to name it CHaMP FIS. I'll hit save. The next thing I'll want to do is create a new GCD project. I'm going to create it in this folder here, UGRCBW05583. Go ahead and hit OK. And I'm going to name it something a little easier than that, just CHaMP FIS. I'll hit OK. Because I have a new GCD project, I'm going to go ahead and add a DEM survey to get this project started. It's not in the map, so it won't be in this drop-down menu. But if I click here on the Browse button, I can navigate to the data folder, which is O_CHaMP_FIS. And I have this data folder here. Under the Visit ID folder, if I go into the Survey Geo database, I have a DEM here. If I go ahead and click Add, I'm going to change this to DEM 2013 because this DEM is from 2013. Looks like it's dimensionally divisible, so everything looks good here. I'm going to go ahead and hit Import Raster. And that came in nicely. So the next step is let's make sure that I have, I'll hit Save and Close. I'm going to go to the Customize menu on the GCD toolbar, go to FIS Library. I want to make sure that I have the FISs that I needed are already, the FIS error models that I need are already loaded here. So we're going to be using these CHaMP FIS, and I have this 3 input, which is CHaMP, which indicates the organization, TS, which is a surveying method, ZErr, which indicates what we're trying to model, and then the 3 inputs follow. So we have point density, slope degrees, and interpolation error. So that's the 3 input that I'll be using. The other one that I'll be using is CHaMP, TS, ZErr, PD, slope degrees, 3D point quality, and interpolation error. So that is there. As we've discussed in previous exercises, these all should be preloaded with your GCD install. And then the final one I'm going to use is a 5 input, and it's this CHaMP, TS, ZErr, PD, slope degrees, SR for surface roughness, 3D point quality, and interpolation error. So I have these 3 loaded in my fuzzy inference system library, which means that they will be accessible to any DEM that I'm trying to create an error model for. So I'll close this, and the next step, if we want to run these, is I'll need to have a raster representation of each one of these inputs. Fortunately, we've provided these for you, so you won't have to create all of these. So I'm going to go to Add Associated Surface by right-clicking this node here. And I'm not exactly sure what I have, so let's navigate to that folder by clicking this Navigate or Browse button, or we can just load an associated surface directly. Click on this Browse button here. And in your data folder, there should be a folder called Associated Surfaces. And here I already have all of them necessary. In reality, I could create the slope with the associated surface tools, but I'm going to go ahead and just load all of these. So first I'll load point density. I'm going to give it a name in case I do make this a larger project or give it a year to it. And it's important when you are just loading an associated surface, if you do want the symbolization, to tell it what type it is, as it won't know ahead of time. So this is in fact a point density. Go ahead and click OK. So now I'm going to continue and add each of my associated surfaces by right-clicking the associated surface node. And I know that we already have the slope in there. You can add it, but because it's just as easy to have GCD calculated it quickly for us, I'll just go ahead and click that calculate slope there, and it'll automatically populate the type for us. So I'll go ahead and hit OK. Brought that in nicely for us. So I've added point density and slope degrees. The next one necessary for our 3 input was going to be interpolation error. So I'll navigate to where that is. It's in the same data folder, associated surfaces, interpolated error. I'm going to change its name to I'll shorten it a little bit, inter 2013. You can name it whatever you want. Again, I'm going to give it a type just so I have a little better symbolization for it. Go ahead and hit OK. Brought that in. You can see interpolation error is very low across the DEM. It's just in isolated regions, but it's important that we pick up that type of uncertainty or error. Okay, now I'm just going to add the final surfaces. We had 2 more. One is point quality, which is point quality 3D here. Add 2013 to the end of that. Looks like it's cleaned up the raster nicely. Gonna give it a type because I do want the symbolization to be standardized. There's a 3D point quality. Kind of a strange looking surface, but that's normal. And then I'll add the final one, which is a roughness. So in this data folder, the IC roughness is in channel roughness and OC roughness is out of channel. Roughness is these two combined. So these are here just if you want to investigate them, but in reality what we'll be using is the roughness raster. Go ahead and hit 2013. And I'll give it the roughness symbolization. Go ahead and hit OK. So there's 2 ways to look at roughness. We have this here. If I want to change the type of an associated surface, I can right click and say edit associated surface property. There's another which is grain size statistic. And if I do that and then remove this surface and then add it to the map, it should take on the grain size categories that we have there. Well, that's really not appropriate, but just want to show you that you can do that in case you do make a mistake here. But I'll give it back to roughness and then it automatically added it to the map. Okay, so now we have our roughness raster, a 3D point quality raster, an interpolation error raster, slope degrees raster, and a point density raster. So we have all the inputs we need for our 3 input, our 4 input, and our 5 input FIS. So let's create those. I'll right click on the error surfaces tab underneath my DEM that I have and say derive error surface. I'll go over to FIS error model. Now this drop down is going to be populated with everything that we had within this FIS library. So all of these will be present in this drop down. So I'll navigate to the 3 input, which is point density, slope degrees, and interpolation error. That'll bring in the FIS inputs that I need to map to an associated surface raster. So slope, I created that. You also could have loaded it. Slope degrees. We have point density, which we loaded. Point density 2013. Then we have interpolation error, which we also loaded. That will be contained here. I'm going to give it a name. call it FIS SLPD int just a nomenclature that I use. You can use whatever you want. Yeah, so with the name set, the correct FIS selected from the drop-down, and the FIS inputs mapped to their representative raster, we should be okay to hit derive error surface. Once that's completed, it should automatically be added to the map. Nicely symbolized. I'll leave it up to you to investigate that. Looks like there are a couple interesting things going on here. I would imagine that the roughness is probably high here. And then these are banks with the high slope. Probably some high interpolation error. Anywho, I'll leave it up to you to investigate those. Where you can click anywhere. I find it helpful if I say all visible layers. Then I get the value for each of them as well as the FIS value, so I can get an idea of why error is high. Just while we're on the topic, if you do want to look at these FIS, you can go to the library, click on the any FIS you want to investigate. This is the one that we're currently using, CHaMP, TS, ZR, PD, SL, slope, deg, enter, and if I click this button here, edit the selected FIS file, I don't necessarily need to edit it, but I can get an idea of what the inputs are for that FIS as well as the rules. And this can be pretty helpful in not only understanding the FIS when you get to an advanced level, but understanding what an FIS file looks like and what goes into making them. So I'll close that. The next step in this exercise is we're going to repeat what we did for this 3 input, but we're now going to do it for the 4 input and the 5 input FIS. So I'm not going to walk you all the way through that, but I will let you know, just to remind you, which FIS you'll need to do that. So the 4 input FIS is this CHaMP, TS, Z error, PD, slope degrees, 3D, Q, enter, That is the 4 input. If I select that, it'll show me the inputs that I need: slope, point density, 3D point quality, interpolation error. And the 5 input is this CHaMP, TS, Z error, point density, slope degrees, surface roughness, 3D point quality, and interpolation error. If I click that again, it'll be loaded with 5, and then I need to map it to the correct associated surface. And don't forget to give it a name. So once you've created the 4 input and the 4 input here and the 5 input FIS here, go ahead and compare them. Maybe use the identify tool with just the FIS loaded, or with also the associated surfaces loaded, and get an idea of what is causing high uncertainty in the different FIS error models. I'll go ahead and save my map just to be thorough, and hopefully we'll see you in other tutorials.